A 4K monitor can cost you from 25,000 to even 1 lakh rupees. Not because of the size or resolution or even the refresh rate, but simply because of the color. And yes, having the exact shades that evoke the exact emotion can make your content going from just good looking to world class. But is spending twice or even 4 times really worth it? And if you do decide to get that expensive color accurate monitor, how do you even make sense of the terms like sRGB, DSIP3, 8-bit, 10-bit? So let's talk about color accurate monitors. So before starting this video, a short disclaimer. So if you're spending extra for color accurate monitors under 27 inch, just don't. We'll explain through this video why. But this video is more focused towards monitors above 32 inch and 4K resolutions because that is where the most confusion lies. And with that, let's begin. The first thing we need to consider is color space. Simply put, color is just light split into 7 wavelengths, 10th class physics, and to identify these different wavelengths, our eyes have 3 types of sensors. One for high wavelengths, one for medium, and one for low. Now, the primary color for each of these sensors is red, green, and blue. RGB. Another thing it tells you that the colors outside the spectrum like pink and brown come from mixing the sensor data in our brain instead of that color actually existing. So understanding that color is actually subjective. In 1931, somebody did some experiments and they started testing how a bunch of people how their eye sensors perceive different wavelengths. Now this data was used to create a map of all the colors our eye can see, and these kinds of maps are called color space. This one in particular is called the XYZ color space. Now depending on the medium and function like print, photography or display, we went on creating more color spaces like RYB, LUV and yes, RGB. Now think of it like this. XYZ is a map of all colors that exist and all the other spaces are models that are trying to capture or represent these colors depending on where these colors are going to be portrayed. Material, TV, XYZ. And RGB is the color space every monitor has used to reproduce colors from real life. This is why color space is super important because it gives you the right context to understand the most important specification of a color accurate monitor. Now starting off with color depth. So every monitor is made of millions of pixels and each pixel has 3 individual color channels, RGB again. And each color channel is divided into bits for adjusting intensity. The more bits, the more unique colors each pixel can create and the more combinations you can make, which is 16.7 million colors. And 10 bits is 1.07 billion colors. Now most monitors are 8-bit, especially the ones under 32 inch, mainly because when you compare a 24 and a 32 inch monitor of the same resolution, each pixel will be roughly 50% smaller in size when you go higher. And it gets really difficult to split the pixels at such a small scale. 8-bit is fine though, as long as you're not working on cinema level or OTT level stuff. So if you're going for 32 inch and above, just find a monitor which is truly 10-bit because a lot of manufacturers will label 10-bit but actually keep an 8-bit FRC under the hood. And 16 million colors, no matter how much they're optimized, will always look stale compared to a 1 billion color. So look for reviews and make sure your monitor is true 10-bit. But that still isn't enough. Regardless of 8 or 10-bit, different types of software optimizations on these pixels can get you different results. This software optimization is the next important specification and it's called color gamut. And the reason why it gets problematic, throughout time different orgs came up with their own software versions with their own made up names, each better than the last. And these arbitrary labels in order are sRGB REC709, worse than DCI-P3 by Digital Cinema Initiative, which is worse than Display P3 by Apple, and Adobe RGB, which are similar, but all of this is under the golden standard REC2100 or True HDR. Like we said earlier, if you're going for 8-bit, you will not get anything above sRGB, which is fine. As is the standard, just looking for the maximum 99% or 100% coverage and you are good to go. Don't go for the highest end ones with all the validations because like we said earlier, if they are 8-bit, no matter how much they are optimized, they'll look 99% same because of the hardware limitation. Now here's a great example. This is a 10K Samsung monitor and this is a 17,000 Pro Watt display. Both 24 inch, one cost double, but the colors are barely different. And when you're looking in 10-bit, try to find the highest coverage in your budget. And if you really want the best of the best, REC2100 HDR is the term you should be looking for. Because that's the only one with true HDR, and all other HDR validation is just software optimization, which is still good, but doesn't compare with REC2100. Now, so these were the two main metrics for understanding colors of your monitor. Apart from that, panel type can also make a big difference, especially with the blacks. because most monitors usually use LCD displays, and the way LCD works is it has a backlit panel with liquid crystals and RGB filters on the front. Now this is very inefficient or slow, and you will never get deep full blacks because the backlight is always on. The filters hamper viewing angles, so while LCD variations might be better or worse in each of these segments like accuracy, contrast, refresh rate and viewing angles, LED is golden because they're just lights which switch on and off as instructed. But again, any LED below 27-inch monitor is not suggested because reaching the size of pixels for achieving 4K is just not possible. And at lower resolutions, you will be able to make out the pixels individually, which is even worse. So for under 27-inch, IPS LCD is your best bet with 99% sRGB. I think most people under this range cannot go wrong with Samsung, and they've been manufacturing displays for the longest time. Even Apple gets their iPhone displays from them. And for 32-inch and above, OLED is a super option. And that's the true LED. And that was that. There are also other factors to consider: refresh rate, response time, curved screens, connectivity, ergonomics, but there's just too many options there and we cannot possibly cover everything in a single video. Luckily for you, we have configuration specialists who can help you choose between these nitty-gritties and help you build the right setup under your budget for your exact use case. So if you want to skip all the hassle of choosing the right hardware, visit one of our stores in Gurgaon, Bangalore, Hyderabad or Mumbai. And if you're not from one of the cities, we've been servicing nationally since 2015 and we ship for free. Until next time, cheers.